All right, 5-7, slopes of parallel and perpendicular lines. You're going to need your Know It notes, page 72 and 73. I'm not going to do very much graphing here. You'll see some graphs on the screen, but I don't think you'll actually need graph paper. Parallel lines, we're going to start with parallel lines. We're going to do everything about parallel lines first, and then we'll do all about perpendicular lines. So on the definition line there up under vocabulary, parallel lines are lines in the same plane that have no points in common. You know that. They look like railroad tracks. They're always the same distance apart forever and ever and ever. They don't intersect. Okay. In that big blue box, I want you to put this. Right? You can draw a nice little sketch. Doesn't have to be on graph paper. And write the words. Two different non-vertical lines are parallel if and only if they have the same slope. Parallel lines have the same slope. That's the key idea here, because right, if they're at the same angle, then they have to have the same slope. Pause it if you need more time here. I'm going to have you add one more thing to that box right now. And whoa, too far. Okay. Also, all different vertical lines are parallel. So add that into that nice big blue box there. Obviously, all horizontal lines are parallel too, but those do have the same slope, right? Those have slopes of 0. Okay. The vertical lines have undefined slopes, but they still are parallel. On page 73, okay, you're going to put some things below where you have that parallel lines box, or you can actually even do it in the parallel lines box. I'm not really that concerned where it goes, but just kind of keep that like the left half of the page for parallel, the right half for perpendicular. This problem is asking you to identify which lines are parallel. Obviously, if we graph them, it's really easy to see which lines are parallel. Right, we have 4 lines here. Maybe we can separate them apart. I don't know. No, they're all stuck together. But you can really easily see 5/3 x plus 4 and 5/3 x minus 2 are parallel. And y equals x plus 1 and y equals x are parallel. They have the same slopes. If you don't have the graph there, then you look just at the slopes with the equation and determine which ones are the same. So now we're going to do one without any graphs. Maybe. Okay. The steps. It's a good idea to jot these down. Right below that parallel lines box is fine. To figure out what lines are parallel, it's really helpful to write all the equations in slope-intercept form, because that's the easiest way for you to tell then what the slope of the line is. If it's in slope-intercept form, right, then the slope is just the number in front of x. So that's nice and easy. Okay? They have the same slope. They're parallel. So we're going to do this one, but I have the equations on the next page so that we have more space for converting them. Okay, it wants to jump 100 slides at a time. There we go. So we're going to do step 1. Write all the equations in slope-intercept form. This one? Oh, look, already in slope-intercept form. Good. This one? Already in slope-intercept form. So we got 2 that are already done for us. Thank you. Okay. This one? Oh, standard form. So let's rearrange. Subtract 2 x's from each side. And we get 3y equals negative 2x plus 8. And then divide everything by 3. Now all I really care about is the slope, so I don't even really need to rewrite it again because I can see what the slope of the line is. And I could turn this one into slope-intercept form, and some of you will really want to, but those of you who are pretty savvy, you'll remember that the equation for point-slope form, this is m, right? M times x minus x1. So I don't really have to put it into slope-intercept form to tell what the slope is. So let's figure out what the slope of each of these lines is. Here we have a slope of 2. Here we have a slope of negative 2/3. Here I have a slope of negative 2/3. And here I have a slope of 3. So which lines are parallel? Which lines have the same slope? All right, we have this one, no friends, but these two lines are parallel. Color that in there. That's supposed to be an arrow tip. So these two lines are parallel. The others aren't parallel. They're not perpendicular. They're just there on the grid. The other thing you need to be able to do is not just identify parallel lines. You have to be able to write the equation of lines that are parallel. So if I give you the equation of a line, or if I give you the slope and a point on that line, can you create another line parallel to that line? So if you think about it pictorially, it's like, here I've given you this. Now I want you to create the equation of a line that's parallel to it, given some specific information about that new line. So here's the steps for this. Once again, probably the best place to put this is page 73. If you're running out of room, you can get a piece of binder paper and add it on. Writing equations of parallel lines. Step 1, find the slope of the line, the given line. You'll be given a line. Okay. Parallel line has the same slope. Step 2, write the equation in point-slope form, or another method if you prefer, and take that point-slope form and translate it into slope-intercept form. Easy 3-step process. It always feels pretty easy for parallel. For some reason perpendicular always feels a lot harder. Okay, this doesn't really belong here, so let's skip that. Okay, we're going to do this problem here. Write an equation in slope-intercept form for the line that passes through the point 4, 10 and is parallel to the line given by y equals 3x plus 8. Now I'm not going to solve this by graphing, but I'm just going to sketch for you for a moment what it would look like, just so you have a good idea of it. So 1, 2, 3, 4, 5, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, give or take. Right, so we've got a point here. And then my y-intercept, that's this point that the new line is going to go through. And the line they gave me, I've got a point at 8 and a slope of 3. Okay. So the given line looks kind of like this. The new line that I'm going to write is going to look something right like this. Okay. It's going to be parallel to that line, the solid line, and it's going to go through the point 4, 10. So the first thing is to figure out the slope. Well, they gave me the slope. It's in slope-intercept form. So the slope is 3. It has to go through the point 4, 10. So hey, this should look really familiar, like 5-6, right? Lesson. You just did a whole bunch of these the other day. Y minus 10 equals 3 times x minus 4. And y minus 10 equals 3x minus 12. So add 10 to both sides, and we get y equals 3x minus 2. Okay. And if I was a better sketcher, then my line would have actually been coming down, should have gone through about here instead, right? And had that slope of 3. So I wasn't too far off, but it wasn't fabulous. That's why you shouldn't draw graphs in free space. That's why you should do graphs on graph paper. I'm not going to do more examples of this right now in the video. We will do more in class, but I don't want to suck up a bunch of video time doing it. So if you feel like you need more examples before you come to class, just take a look in the textbook, and I'm sure you can find at least 3 more. But we right now are going to move on to perpendicular lines. So back on page 72, up there at the vocabulary, you're going to write the definition for perpendicular lines. So they are lines that intersect to form right angles. In the box, the big blue box on page 72 at the bottom, you're going to put this information in words and a nice little sketch. 2 non-vertical lines are perpendicular if the product of their slopes is -1. It's a good idea to put this part too. Slopes are negative reciprocals of each other. And if you look at the one in the picture, we have the slopes -2/3 and +3/2. When you multiply them together, you get -1. One is the flip of the other and opposite sign. That's what's going to happen all the time. So if I have a slope of 5, the negative reciprocal, the perpendicular line, would have a slope of -1/5. The other thing I want you to put in the box, all vertical lines are perpendicular to all horizontal lines. Okay, that should be pretty intuitive. You can make a quick sketch of it and jot that down. We're going to follow kind of the same pattern here as we go through. So the first thing we're going to do, now that we have all these definitions down, is we're going to look at some lines and see if we can figure out which ones are perpendicular. We're going to do this pretty much the same way we did with parallel lines. We want to put them in slope-intercept form, and then we can pick out the slopes and figure out which ones are perpendicular. So let's, y = 3. Well, that's a horizontal line. And x = -2. The next one, that's a vertical line. Are those perpendicular? You betcha. Symbol for perpendicular is a upside down T, by the way. So we can say that those are perpendicular. Now let's look at the other two, see if they're perpendicular. We have y = 3x and y = -1/3 times the quantity x minus 4. It's not quite in slope-intercept form, but it is more in point slope form. The -1/3 has to be m. And m here in front of x. So are 3 1/3 opposites and reciprocals? Absolutely. Positive, negative, 3/1, 1/3. So these are also perpendicular. We got one more of those kind of problems to try. So let's spread them out, see if we can figure out which ones are perpendicular. Go ahead and pause the video and try it on your own. Now that you're back, I'm still writing the problems down so that I can pick out the slope from each of them. Okay. Well, I know once again that these two, one is a horizontal line and one's a vertical line, so those are perpendicular. Let's check this part out. We have here a slope of 5, and here we have a slope of -1/5. They are negative reciprocals, so those two lines are perpendicular to each other. It won't always be so nice and neat. Sometimes there'll be leftover ones that aren't perpendicular or parallel, or vertical or horizontal. This looks like a lot of writing, but really, you don't even have to rewrite this, because this is about writing the equations in slope-intercept form. The only difference here is that you need to remember when you find the slope that the perpendicular line has a slope that is the negative reciprocal. So if the slope of the given line is 2, the slope of the perpendicular line would be -1/2. And here's how I always write it. I write down the slope of the given line, and then I write down perpendicular m, and I write it again for myself. From there, you have the slope, you've got the point, and you'll be good to go. Let's try one together. And like I said, we're not going to do a whole bunch in the video notes. We'll do more together in class. And I am going to sketch again. I know my sketches aren't the best, but I think it does help you see things. And maybe next year I'll remember to put graph paper on so I could do a better job. So we're looking for the line y = 2x minus 5. So here's my y-intercept, and the slope is 2. Okay, so my line looks something like this. And I'm going to change colors, so I'll make it a little easier to see. How about, no, I want green. There we go. All right, and then my perpendicular line is going to go through 2, -1. And it's going to be at a right angle. Okay, so it's going to look something like this, right, and have a right angle here. So let's see if we get a y-intercept of something close to 1. We know the slope of our given line, it's 2. The perpendicular slope, it's exactly the example I was doing on the previous page, is -1/2. Flip it and make it negative. And now, point slope form. Y minus negative 1, we're using this point, equals negative 1/2, make sure you use the perpendicular slope, times x minus 2. Distribute, and we get negative 1/2 x, negative 1/2 times 2 is positive 1. And then we're going to take 1 away from each side. Oh, I was pretty close. It's supposed to go through 0. Y equals negative 1/2 x plus 0, or just y equals negative 1/2 x. So that's the equation of the perpendicular line. And if I'd done it really well, it would have gone through 0, 0. It's pretty close. And that's where we're going to stop. Parallel lines, same slope. Perpendicular lines, slopes are negative reciprocals.